Meat and potatoes, vitamin B6, and the Aryl Hydrocarbon Receptor. This is Obesity Explained, Episode 9, featuring the Humble Spud. On the last episode, we talked about how either B12, vitamin B12, or folate deficiency can activate the Aryl hydrocarbon receptor. Folate helps to shut down the Aryl hydrocarbon receptor postprandially. So remember that the AhR is activated after every meal by insulin, and you have to then shut it down, which folate does a good job for that. And you need both of them. You need both B12 and folate for proper methylation, but also postprandially. And a deficiency in either one is associated with obesity, and that is with, in human studies, either deficiency. And so we're back to the methylation pathway. And so the last time we talked, of course, about B12, and that's this underlined in red, and folate, which are the green underlines. And I did that, of course, because folate typically comes from plants, and B12 comes from red meat as well as other sources. But this time, to make it actually all the way through these cycles, you also need vitamin B6, which is part of the folate cycle, and it's underlined in yellow there. And you also need riboflavin, which gets you this FAD. FAD is made from riboflavin. And so you actually need really all of these B vitamins working together for proper methylation. And interestingly, last time we talked about high homocysteine, and B6 is useful for converting extra homocysteine down to glutathione as well. And so in this episode, we're going to talk about the role of B6 in human obesity. And this is B6 here. You can see it is a six-membered aromatic ring with a nitrogen over here, and it's decorated with some oxygens. It has long, blonde, flowing locks. And we'll talk about what are the traditional food sources of B6 in the traditional American diet. We'll get into the nerdy stuff. Of course we will. How it affects the Aryl hydrocarbon receptor. And then we're going to look at the dark side of B6. And you see there that B6 now is throwing a hand grenade. And so this is a study of vitamin status of people who have showed up for bariatric surgery. And they're comparing morbidly obese patients with normal controls. And you can see there are a bunch of vitamin deficiencies. This is vitamin C. The obese patients are significantly lower in vitamin C. They're lower in vitamin D. This is very common. And for some reason, only in men. They're also low in folic acid or folate compared to controls. And so we'll come back for sure to vitamin D. And we already talked about folate. But also in these morbidly obese patients, what you see is a very real deficiency in vitamin B6. So you can see in women, the very obese women have serum levels of 29 nanomoles per liter, and lean women have 46. So that is a pretty massive decrease in vitamin B6 status. And this is another study of people undergoing bariatric surgery. And you can see that again, in this study, 27% of the patients have low vitamin D. And then the B vitamins, vitamin B6, B12, and folate are low in a significant percentage of them. B6 is only 11%, but this graph sort of shows the distribution, and these dotted lines are considered the low level of normal folate. And this dotted line is the sort of the upper level of what's considered normal. And you can see that even though only 11% of them have a definitive, vitamin B6 deficiency, all of the people are clustered in the lower half of the normal range, right? There's very few above the midpoint, which would probably be somewhere around 12, right? And this is yet another study. And again, you can see nutritional deficiencies. This is in China. And so they're almost 80% of them are low in vitamin D. Again, we'll come back to vitamin D. But you also see vitamin B6 is low in 28% of the people. Folate is low in 27%. So these are pretty significant percentage of people with obesity low in B6 and folate. And so This paper I've actually referenced in almost every one of these almost every one of these episodes, but we're gonna actually really dig into what they found today. And so this PLP is the active form of vitamin B6 in the body, and so those studies I just showed were in severe obesity. That was bariatric surgery, but this study showed in China. So these are just normal Chinese people, and what you can see is that even in people that are only overweight, so not even obese, you already see this very real drop in vitamin B6 circulating active levels. And then in obese Chinese, the levels drop even lower. And that is really interesting because what they also did was they put mice on a high-fat diet, this diet that's designed to make mice fat in the laboratory, and their actual circulating B6 levels drop by about half, or by almost half, when they're put on the high-fat diet. So it's not that their diet is deficient in B6, but something about that high-fat diet, or whatever that high-fat diet does to them, shifting them into a different metabolic state, reduces B6 availability. And they also showed that in those mice on the high-fat diet, if you supplement them with B6, you can prevent most of the obesity caused by the high-fat diet itself. So that's interesting. And so I want to talk for a second. So where do we get, traditionally, where did people get their vitamin B6 from? This is that same Cornell cooperative extension study that I referenced the last time. It's from Bulletin 478 from February of 1942. And what they're looking at is they're looking at farmers in upstate New York. So these are almost literally my neighbors. And you can see this is farm furnished food used by the Gleasons, a particular family in 1940 that were highlighted in this pamphlet. And the family has about three, there's a mom, a dad, they have one hired man who eats meals with them, and they have three kids that I think are like 15, 13, and 9, right? So you got 6 people, and you can see what they eat. And so first off the bat, they consume 2,200 quarts of milk over a year. And if you do the math, that works out to 1 quart of milk per person per day. So that's quite a bit of milk. And then you have cream too, 365 quarts of cream a day. That works out to 1 quart per week per person. And those little, half pints of heavy whipping cream that you can buy at the grocery store, that means that every person would have consumed 4 of those every week. And then eggs is another big one. So 365 dozen eggs a year. That's a dozen eggs every day. Obviously, that's about 2 eggs per person per day. And meat. And so this is very classic. And I've seen this in any number of books and old time references and all these places that the classic thing that farms did was they would raise 2 pigs for their own meat needs for the year, and then they would split a cow with the neighbor. And so every year they'd have these 2 whole pigs and a half cow basically. And of course, back in the day, they didn't have freezer, right? They didn't have chest freezers. And so what would happen is on the week that you slaughter the animals, you would have sort of a feast of fresh meat for the next week, but then everything else would have been put into the smokehouse. And so the pork would have been heavily salted, turned into, cured smoked pork and kept in the smokehouse. And so that was kind of what happened. This is by 1940, so people did have more access to refrigeration and freezers. But anyway, all of this meat, 750 pounds of meat sounds like a lot, but it actually for 6 people is only about 5 ounces a day of meat. And so, the diet is actually not that high. There's this idea that the traditional American diet is like meat and potatoes, right? And that's sometimes that's said in a kind of derogatory way, but meat and potatoes, right? And so, but these are actual American farms, and actually, 5 ounces a day of meat is not really that much. And here's Miss Gleason, and she's showing off her very impressive array of canned goods that she's put away for winter. And you can see she's put away, that's like 600, 600 quarts or 600 jars of, that is so much work. It's unbelievable. But you can also see that a lot of the things are very high in folate, such as the 25 quarts of pickled beets, the 18 quarts of lima beans, the 13 quarts of shell beans. And then they also show what is in the Gleason's root cellar. And so, you can maintain a cellar underneath your house through the winter at a very cold temperature, below 40 degrees. And essentially, the whole cellar becomes a refrigerator. And so, you don't use the root cellar the whole year. Basically, you fill it up in September and October, and then the idea is that by May it's all gone. And so you've got about a 6-month supply down there. Most things will not last in a root cellar much more than 6 months, anyway. And so, what do they eat in the 6 months? So they've got 500 pounds of cabbage down there and 50 quarts of sauerkraut, right? And so that is a lot of green vegetables. Cabbages, of course, store very well in a root cellar condition, and it's cold in New York. In the South, you can, I talked in the last one about turnip greens, and you can extend the season a lot more in the South than you can in New York. And so in New York, we use cabbage, and cabbage is a decent source of folate. And so you've got a pretty good stash there. And they also have 30 pounds of beans, and I assume that means dried shelled beans. And that is another fantastic source of folate. And so you can see these upstate New York families were putting away a lot of folate for winter. And they also have 250 pounds of squash. Squash turns out to be a very good source of vitamin B6. But what's really down there is 50 bushels of potatoes. So a bushel of potatoes weighs about 40 pounds. So they literally have 1 ton of potatoes, and over a 6-month period, that works out to about 2 pounds of potatoes per person per day. And so here are the Gleasons. There's the 6 sort of people that normally eat there, and they've got their massive pallet of potatoes and their pallet of cabbage, and they are ready for winter. And you might be wondering, okay, well, with all this cream and all of these potatoes, how do they eat all those? This is the Farm Journal Country Cookbook from 1959. This is the Farm Journal was a very popular magazine, and people would send in their own recipes, and their recipes would get published in the magazine. This is a collection of recipes that were published in the magazine over time, and they have a whole chapter on potatoes. And this is the first recipe in the potato chapter, and it is skillet cream potatoes. And basically what you do is you boil potatoes, and then you put them in a skillet with cream or sour cream and wait for the sour cream to get absorbed into the potatoes, and that is potatoes, right? So you could get rid of a lot of cream and a lot of potatoes that way. And so that traditional meat and potatoes American diet is really more a milk and potatoes diet, right? The 5 ounces of meat is actually a really good vitamin B supplement, but the bulk of that of those vitamins are going to be coming from the potatoes and the milk. And you can see here's a list online of the top foods high in vitamin B6, and you can see potatoes is on this list. And actually, when you think about it in terms of like B6 per calorie, potatoes are a very high source of vitamin B6. And so meat is also a good source of vitamin B6, and you can see potatoes land, in terms of B6 per calorie, they land right between beef tenderloin and wild coho salmon. Greens are also a decent source of B6. They're sort of low overall, but they don't provide a lot of calories, so you can stuff down a lot of greens without a lot of calories, and you will get a decent amount of B6 from those as well. Over the weekend, I made a bunch of these lists of, just because I was curious about the metric and I couldn't find it anywhere, so I downloaded the USDA database. Anyway, you can now go to fireinabottle.net and pull down the nutrient lists thing, and I've got a bunch of these lists of, I've got B6, B12, folate, highest per calorie, and then I also have one about foods highest and lowest in linoleic acid. gin is very low in linoleic acid. I found out in making this list. Anyway, and so is white sugar. A lot of great things on that list. Anyway, and so how much, right? So they've got 2 pounds of potatoes per person. That's about 900 grams. You figure after you peel them, trim them, you probably have 700 grams of potatoes that actually get served. That's about 2.8 milligrams of vitamin B6 just from the potatoes that the Gleasons have, right? And the suggested US RDA amount is less than 2 milligrams, even for older women and men. And so that amount of potatoes is all of the vitamin B6 that they need for the 6 months of winter. And those potatoes are also providing 180% of the US RDA of vitamin C, because potatoes are very high in vitamin C. And you saw on those lists that obese people are also low in vitamin C. But in addition to its role in methylation, B6 also has a crucial role in tryptophan metabolism. And so here's tryptophan. Tryptophan is an amino acid. It's in every protein that you eat. So all your food has tryptophan. Some of it gets used to make protein or used to make serotonin, but some of the rest is converted to something called kynurenine. And there's good things that can come out of this. So this whole pathway, nicotinamide, this is used to make NAD+, right? We like having NAD+, that's great. But what you see is that every road that leads from kynurenine needs B6. So these things with the red underlines, these little circles that say B6, these are all enzymes, and they require vitamin B6 to do their job. And so you can make kynurenine or you can make hydroxykynurenine, but without, and you can see again, B2, there's riboflavin again. But what happens is without B6, kynurenine builds up. And as I've said in previous articles or episodes, kynurenine is one of the endogenous natural activators of the aryl hydrocarbon receptor. And so you can see that if B6 is low, you're going to have a kynurenine buildup. You're going to have an activated AhR. So again, we already saw this, but this is just showing again that vitamin B6 is low in overweight and obese humans. And when you put mice onto a high-fat diet, they become low in vitamin B6. And what happens? Well, kynurenine goes up, right? And so this is in humans. This is the correlation between plasma kynurenine and vitamin B6 in actual walking around humans in China, right? And you can see as they go from lean to overweight to obese, kynurenine goes up. And these are the mice, right? And so in that high-fat diet, B6 goes down, kynurenine goes up. And just to, see why this is, you literally can't go anywhere from kynurenine. You cannot make anything else. You can't go back to tryptophan. This is irreversible. So if B6 is low, kynurenine builds up, AhR is activated. Again, I think I already said this. Kynurenine activates the aryl hydrocarbon receptor. As B6 goes down, kynurenine goes up. And so here's the AhR doing its thing. And so what they did was they looked at all of these tissues in these mice on the high-fat diet. And IDO1 is a target gene of the aryl hydrocarbon receptor. And so they were looking, where is this IDO1 elevated? And what they saw specifically is it's dramatically elevated in white adipose tissue. So most of your, that just means your fat tissues, subcutaneous tissues, things like that are all white adipose tissue. And so specifically B6 deficiency or this high-fat diet seems to be activating the AhR in adipose tissue and driving expression of this gene called IDO1. And so then they took humans and they did adipose tissue biopsy, and they showed that the obese humans have dramatically higher IDO1 activity specifically in their adipose tissue. And you see this very direct relationship between IDO1 expression and BMI. So as people become heavier, fatter, they have more IDO1 expression, and IDO1 expression is an indicator that you have an elevated activity of the aryl hydrocarbon receptor in your adipose tissue. And to see how this all works, just again, so the AhR is activating IDO1. And so when IDO1 is activated, you actually are converting more tryptophan to kynurenine. And of course, the kynurenine has nowhere to go because vitamin B6 is low. And of course, kynurenine activates the Aryl hydrocarbon receptor. And so you see this positive feedback loop happening because it's biology and it's always a feedback loop. But you see this loop of AhR activates IDO, which increases kynurenine. Something about the high-fat diet lowers B6. That creates a higher buildup in kynurenine, and that kynurenine activates the Aryl hydrocarbon receptor, and around they go. And so they further did some testing. They actually showed that this is in tissue culture. They showed that if you put these things in tissue culture and you give them increasing amounts of kynurenine, the amount of Aryl hydrocarbon receptor protein goes up. And the reason for that is that the Aryl hydrocarbon receptor is a target gene of the Aryl hydrocarbon receptor. The Aryl hydrocarbon receptor turns on the Aryl hydrocarbon receptor. So that's another positive feedback loop that happens. And these are lipogenic genes here. And you can see that. Another thing that happens when you give the cells kynurenine is that lipogenic genes go up because the Aryl hydrocarbon receptor is ultimately in charge of turning on the lipogenic enzymes. And lipogenic means fat making. And so PPAR gamma, I have depicted here as the cold miser from, if you remember, the Christmas special with the cold miser and the heat miser. And one of the reasons for that is this table. And so one of the things they did with these mice is they made a adipose tissue, so a fat tissue knockout of the gene IDO1, right? And so they're trying to break that loop of high IDO1 and low B6 leads to increased kynurenine, which activates the Aryl hydrocarbon receptor, which makes more kynurenine, right? And so one of the ways you can break that cycle is you can just eliminate the gene IDO1 in the adipose tissue. And so they did that, and you can see this is the kynurenine in the adipose tissue goes way down if there's no IDO1, right? Because now you're not converting all of that tryptophan to kynurenine. So kynurenine goes way down, and the metabolic rate of the mice actually go up. They actually produce more heat. And so this is a heat map of the mice. You can see there's a lot more green and red colors in these mice compared to the normal mice on a high-fat diet. And so if you break that feedback loop, the mice are actually able to do more thermogenesis, and they have a higher metabolic rate, and they lose about 10% of their body weight compared to normal mice. And so then another thing you can do to break up that cycle is you can delete the Aryl hydrocarbon receptor from the adipose tissue, right? And so they did that, and there was a small decrease in plasma kynurenine, not as big as you might expect. But those mice that have zero AhR activity in their adipose tissue have a pretty significantly increased metabolic rate, ability to create heat, and they lose about 15% of their body weight, right? So they do, the AhR knockout mice are leaner than the IDO1 knockout mice because, of course, IDO1 is only one of the many things that the AhR is doing in the adipose tissue. And then lastly, they were like, okay, well, we could just give them more vitamin B6. And this actually worked better than either of the other two things, probably because B6 is having a systemic effect, right? It's fixing the methylation issues in the liver as well as fixing the kynurenine issues in the adipose tissue. And so you can see that, again, PLP is the active form of B6, and you can see in the high-fat diet, the PLP levels go down. But over here, these are mice on the high-fat diet with supplemental B6, and you can see that adding B6 to their diet does, overcome this issue of dropping B6, and they, in fact, have much higher B6 levels. Kynurenine levels drop because, of course, if you have B6, you can go ahead and convert the kynurenine on to the other things, right? And the change in body weight is they probably lost 25% of their body weight. So vitamin B6 caused the mice to be much leaner than either adipose-specific AhR or IDO1 knockout models. And so does this work in humans? This is a human study. This is the hydroxykynurenine And this is B6 levels. And so you can see people with the lowest B6 have the highest kynurenine, the highest hydroxykynurenine, and people with the most B6 have the least hydroxykynurenine, right? So that makes sense. And so these people here were given a B6 supplement, and this is kind of a weird chart to interpret. This is 0. So everyone in this study had their hydroxykynurenine levels lowered with B6 supplementation. But what they're trying to show here is that people who had the least B6 starting out, they probably had the highest kynurenine. Well, they did have the highest kynurenine levels, and they're the ones who had their kynurenine levels lowered the most. So if you had very low B6 status and you started taking this B6, your kynurenine levels were lowered by over 40%, and that's pretty good. There's not a ton of weight loss studies in people with vitamin B6, but there are some interesting things. This is a weird study. They took women and they put them on a low-calorie diet, and some of the women ate more vegetables, and some of the women ate more breakfast cereals, and the breakfast cereals were fortified with vitamin B6. And so what they found is that only in the women whose active vitamin B6 levels were increased, they had a higher fat-free mass as a percentage of body composition. And so that's interesting. This is another study looking at, they supplemented branched-chain amino acids and vitamin B6, and they saw a significant time and treatment interaction in waist-to-hip ratio and some other indices of body composition. So that's pretty good. And this is in women with gestational diabetes. And this is from 1977. And so what they showed is that vitamin B6, this is so they eat a meal here, and this is their blood glucose over time. And so you can see this line here, this lower line is women with gestational diabetes who have had vitamin B6 treatment, and you can see that the vitamin B6 helps them lower their blood glucose, which seems like a good thing. But I also want to talk a little bit about the dark side of vitamin B6. So this is the paradox of pyridoxine supplements, and you can see their vitamin B6 has its hand grenade. And so this study came out in 2018. So I showed those 3 studies in the beginning where people coming into bariatric surgery have low levels of vitamin B6. And this little graph that I have on the right is from one of those first 3 studies. And you can see everybody is pretty much clustered below 10 micrograms per liter. But this is a 2018 study, and it's in Kuwait. And they saw that people were low in vitamin D and B12. But interestingly, they saw no cases of vitamin B6 deficiency, while in a remarkable 24% of patients, there was actually excessive vitamin B6, hypervitaminosis B6. And they go on to say that excessive increases in B6 levels might lead to sensory neuropathy, with gait changes, peripheral sensation, and lack of muscle coordination. And that is kind of disturbing, but that also sounds like vitamin B12 deficiency, the idea of sensory neuropathy issues. And so what is happening, right? This study is completely in contradiction to all of the other studies that I showed. What has changed? And so in the past 20 years, as you probably know, energy drinks have become very popular, and energy drinks are loaded with vitamin B6. This is a single 12-ounce can of Red Bull has 360% of your daily allotment of vitamin B6, right? And so this study in Kuwait, just to confirm, I don't know what they drink in Kuwait, but it shows that 58% of adults, young adults in Kuwait, say that they drink at least one energy drink per month. And, you know, there's a lot of studies where people will drink 6-8 of these energy drinks in a day. So that might be going towards the hypervitaminosis B6 that we're seeing. That's just my guess. And it said there, so this is the peripheral neuropathy of vitamin B12 deficiency, right? And so this is a commonly known thing. Vitamin B12 deficiency causes the same symptoms that having a super high level of vitamin B6 causes. And that's interesting because I also showed in the last talk, this table's from that, is that B12 deficiency causes an overactivated aryl hydrocarbon receptor. So that all is very interesting. And so, it kind of makes you wonder, are all of these B vitamins interacting with the aryl hydrocarbon receptor? And so I looked at some of them, and this is riboflavin, right? And this is TCDD, the thing that we use in the lab to activate the AhR, and they're like almost dead ringers. I mean, sure, this oxygen group has moved over from the corner, but, you have this big, basically fat-soluble molecule with these polar groups posted here in the middle and on the corners. And that is what riboflavin looks like. And so it turns out this is a paper from 1985. Lumichrome, which is pictured here, a metabolite of riboflavin, is the first known endogenous chemical in the rat to exhibit affinity for the TCDD receptor, which of course is another name for the aryl hydrocarbon receptor. And so this was shown back in 1985, but I'm not even sure. I couldn't find out whether lumichrome activates the AhR or suppresses it. We don't know, but this is apparently a common metabolite of riboflavin, and it interacts with the AhR. We can say that. And so then I looked at B6, and in the last episode, we also talked about this molecule, PABA, which is from folate and inhibits the AhR. And boy, B6 looks a lot like PABA. You've got this 6-membered aromatic ring. You've got, it's sort of studded with these more water-loving groups, these more polar groups, these oxygens and this nitrogen. And the PABA has the nitrogen on one end and the oxygen on the other end. It looks possible, right? And so, but no one's really studied this. This is just me speculating, really. But I did find this study. So they took these mice and they gave some a vitamin that was, or a diet that was B6 deficient. And what you see is that CYP1A1, which is of course a target gene of the AhR, these are in mice with a normal amount of B6 is about 37. That's the relative level of CYP1A1. And in B6 deficient mice, it's 44. And so you see this increase in CYP1A1 levels due to vitamin B6 deficiency. And this is exactly what you would expect based on the study that we went through, where low B6 causes increased kynurenine, activates the AhR, right? And what they also showed was this S2 was when they gave them B6 for 2 days, and this S3 is when they gave them B6 for 3 days. So within 3 days, this elevated CYP1A1 level returns back to normal, right? 36.85 versus 36.66. So in 3 days, given B6, CYP1A1, which is to say aryl hydrocarbon receptor activation levels, go back to controls. But interestingly, the mice who started off with sufficient vitamin B6 levels, if you gave them a vitamin B6 supplement for 3 days, their level of CYP1A1 expression goes way up. It goes up to 43. That's almost as high. That's about the same level as the mice who were deficient for their whole life. And so this is very interesting. This suggests to me that in certain cases, vitamin B6 could be, again, this is very speculative, but vitamin 6 could be an activator of the AhR. And that's very interesting. This is again from that last study. This showed that this is triglyceride levels, but this is in folate deficient rats. This is in B12 deficient rats, right? And so both of them are very bad. But interestingly, the mice that didn't have either one were kind of better off than one who were low in either or. And that is really interesting because I've been sort of painting this idea of activating or blocking the AhR as this kind of binary issue, but it's really not. It's a very complicated dance with all of these molecules that are potentially activating it and potentially blocking it. And this is an interesting case. This is quercetin. Quercetin is a polyphenol, a flavone. It's in a lot of things. Onions are very high. And so this I've sort of blown up to make it look a little more dramatic from this very long chart with a very tall vertical axis. And so what happens is you go from 0 quercetin, this is in tissue culture, to 1 micromolar to 10 micromolar is in the black quercetin. It actually doubles AhR activity, roughly. The quercetin does. And so we can say that quercetin activates the AhR by roughly twofold. But, however, in a different context, TCDD, of course, is a very strong activator of the AhR. And so in this graph, in the same paper, they add TCDD, and you see that AhR activity goes up 14-fold-ish. But then this is with 1 micromolar, and this is with 10 micromolar. Quercetin, it actually blocks the activation by TCDD of the aryl hydrocarbon receptor by 4-fold. So because it's also binding, right? It's binding to the same binding pocket of the aryl hydrocarbon receptor. And it's not nearly as strong of an activator. And so you see this competition. And so depending on the context, quercetin might activate the aryl hydrocarbon receptor or might block the aryl hydrocarbon receptor. And so when you look at all these B vitamins and the way they're interacting with aryl hydrocarbon receptor, you have to wonder, is something like that happening? Is there some kind of, because if the job, as I've suggested, of the AhR is actually to, sort of gauge all of these incoming signals from the environment and determine is swimsuit season coming up and should we be leaning out, or is winter coming and we should be fattening, right? And if that's your job, you'd of course be very interested in what's happening with all these B vitamins. And so now I'm just so onions are a very good source of quercetin. Everyone's now running to their pantry to throw out their onions because it activates the AhR. Hold on for a second. Onions are actually not high in quercetin specifically. These are a bunch of different varieties of onions. Here's the amount of quercetin. And this is what happens to quercetin in onions. Most of them are either as quercetin 4-glucoside, which is this thing that has a glucose stuck on it, or quercetin 3,4-diglucoside, which is this thing here, which has 2 glucose molecules stuck to it. And interestingly, the biologically active fate of quercetin glycoside or glucoside is this thing called DOPAC. And DOPAC does not seem to activate the aryl hydrocarbon receptor in the same way that quercetin does. And so you can hold on to your onions for the time being. And I wanted to think again about our friend, the grizzly bear in Yellowstone Park, deciding whether or not it's swimsuit season or fattening up season. And this is the grizzly bear's food over the course of the year. And you can see these two things, the G and the F, right? This big channel here, those are green plants. So that's going to be their best source of folate. And this channel here, which is sort of increasing as the year goes on, that's roots. And they eat a lot of roots that are similar to potatoes and probably, if I had to guess, good sources of vitamin B6. And I, that means insects, but they mostly eat ants. And so what you see is as you pass swimsuit season, which is sometime around here, what's happening is the ratio of folate to B6 is decreasing, right? Less green things, more roots and ants, which are probably also a good source of B6 if I had to guess. And so you could see a scenario where B6 is helping to lean you out here because it's dealing with the kynurenine system, but in this context, the folate could be, again, this is completely theoretical, the folate could be blocking B6 from directly activating the Aryl Hydrocarbon Receptor. And as that folate consumption drops and you still have a ton of B6 coming in, you could have a scenario where the B6 is actually helping to flip you into fat storing mode. Again, very speculative, but that would explain why all of these people drinking energy drinks, beyond just all of the sugar, right? All these people drinking energy drinks might be running off to get bariatric surgery because very, very high and unbalanced B vitamins with all of that sugar might be a great ticket to weight gain. And so in conclusion, this is why, and so right, this conversation is very complicated. We don't really know what's happening with all these B vitamins and their hydrocarbon receptor, and oh, by the way, other nuclear receptors. I've been focusing on the AhR, but of course there's a whole bunch of them that are probably involved. And so that's why I go back to thinking about, well, what was the traditional diet that kept Americans healthy for all of those decades? Thanks to Martha Stewart for this photo. Obviously, this is greens and potatoes cooked together. You've got your glass of milk here and a portion of, a 4 or 5 ounce portion of ham or pork, which of course was the most commonly eaten meat on the homestead. Obviously, the greens are the source of folate. The potatoes and the ham are the B6. You're getting riboflavin from the ham and from the milk. The milk is the best source of B12, but as I said in the last one, it also helps you to absorb the folate from the greens, and you have a very balanced and high incoming source of vitamin B12 as opposed to just gulping down Red Bull. So next up, stay tuned for this. This is going to be a very controversial episode. 10 is going to be very controversial. I'm going to make the redox case for starch. So stay tuned for that.